Okay, let's give you guys some practice. So given a function f of x equals this thing here, and also given that f of 2 equals 14 here, find the equation of the tangent line and the normal line of the inverse of this function here at 14, 2. So what that means is this red line here is the is this function here. So when you come to draw the inverse of this function here, remember the inverse is really a reflection along the y equals x line. So just have a guess. So when you come to reflect a red line here, where it crosses the blue line, that's where it will stay the same. So just have a guess of what this will look like when you reflect it. So this is this bit here. It seems like it crosses at -2. So the inverse will cross at this point here, and then this here would be somewhere around here. Oh, you know that when you put 2 into the function, so 1 is here, 2 is here. When you put 2 into the function, it will spit out 14. So 14, well, 14. So this here is 5, 5, and then 10, 15. So just have a sketch. 15. So 14 must be around here. So your function here will look something like this. Okay. So the inverse will be, well, if you at the moment you've got 2 comma 14, so the inverse must be 14 comma 2. So 14 is here, comma 2 will be here. So your inverse graph will look something like this. Okay, hang on, this bit here will be somewhere around here. So yeah, so it will look something like this, and then this bit here will do something like this. So just have a quick sketch. Okay, oops. So just have a quick sketch. So your aim is to really find out the gradient at this point. From here, then you can find out the gradient of this point here, and your job is really to find out the equation of this tangent line and the normal line here. Okay, find out the equation of this normal line, and well, anyway, do whatever you have to do here. Find the equation of the tangent line and the normal line. So press pause and have a go. Okay, so to do this here, yeah, you sketch it roughly. It will give you your this here should be your inverse. Your inverse function will look something along something like this. Okay, and then start. Yeah, so you will need to find out the gradient at this point, because ultimately you will need to know, in order for you to find out the equation of this tangent line here, you will need to know the gradient at this point. In order for you to know the normal line, you will also need to know the gradient at this point. You see, if you can work out the gradient at this point, then from here you can jump to here. So your first step is to find out the gradient at this point here. So you've got an equation here. This equation here is this red line here. So differentiate it, and that will give you the gradient at that point here. So our first step, start out with our function here. Okay, so start out with our function here, and then differentiate it. That would then give you this, and then you want to know the gradient at this point. You want to know the gradient at this point here. So you need to put 2 into f prime. Okay, so you need to put 2 into f prime here, and then blah blah. So the gradient at that point would be 16. Okay, now that you know the gradient at that point here is, now that you know the gradient here is 16, then the gradient at this point will always be the reciprocal of this. So it will be 1 over 16. So the gradient here, the gradient of the tangent here will be 1 over 16. So the equation of the tangent line is, remember, it's going to be y equals mx plus c. This is your gradient here. So this is your gradient here. Put it into here, and you know it crosses at 14, 2. Okay, so you can put this 14 into the x, and then this 2 here goes into the y to work out your c, and then blah 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 here. C turns out to be this. So therefore, the equation of the equation of the tangent line is given by this. Okay, so now that you know the equation of the tangent line, which is this bit here, the equation of the normal line will be the minus reciprocal of this. Okay, so at the moment the gradient is 1 over 16. So take the reciprocal. Well, you need to minus the reciprocal version of this thing here. So the gradient or the normal line will be minus 16. Okay. So that would then give you this, and then yeah. So you know the gradient of the normal line will be minus 16. Will be minus 16, and you know it crosses at this point here. It crosses at 14, 2. So put this 14 into the x, put the 2 here into the y, and then work backwards to find out c. C turns out to be this, and then therefore you can work out, well, therefore the equation of the normal line will be minus 16x plus is that right? Well, I don't know. Well, plus this. Okay, so this here is your equation of the normal line. Okay.